Yo, let's go. I'm so excited for a trip this year. Oh. Oh. So, since I cannot go camping this year, I decided to make my own star sky using three.js. Firstly, we'll need a dataset of the stars in the night sky. Luckily, we can get the Yale Bright Stars catalog for that. The catalog is a byte-formatted text file, with each line containing information of a single star. Of the columns, we'll need these ones: the right ascension and the declination, which is the equivalent to the latitude and longitude of the star's coordinate in the sky dome; the visual magnitude, how bright it is when being viewed on Earth; and the BV index, which describes the temperature and subsequently the color of the star. I made a Python program to read the text file and output a JSON file with the crucial data, which can be then used by the JavaScript code. Alright, now it's time to make the page and put the stars on the sky. We start the JavaScript code by creating an empty scene along with an orbit control for turning the camera. As I mentioned, the location of a star is identified by the right ascension and declination. They are like the latitude and longitude of the sky dome. From the sources, we can find these equations to convert the angles in the astronomical coordinates to the Cartesian coordinates. We're just simulating what we see on Earth without the need of going up to space, so we can just put distance as the same arbitrary large number. The sphere objects for the stars will be scaled by their visual magnitude. The brightness magnitude is measured on a logarithmic scale, and the lower the value, the brighter the star is. Create and add the objects to the scene at the calculated x, y, and z coordinate, and here we go. Let's rotate the camera around to see if I can find any constellations. Atop our viewpoint should be the star closest to the celestial North Pole, aka Polaris. And this here is the famous Great Dipper, with its last two stars pointing towards Polaris. Then we can start adding colors. A sky with only white dots is boring. After all, the stars comes in many different colors. Trouble is, how do we get the RGB color from the temperature in the BV index? I did a search, and of course, someone already made an algorithm. You can literally find any obscure arcane dark magic of coding on Stack Overflow. We just put the value in the function, and it will output the correct RGB colors. However, looking at a bunch of solid colored dots is still not very visually pleasing, which is why our next step is to add shaders. A shader is basically two functions that runs on the GPU. The first one outputs the coordinates of each vertex. The second one outputs the color of each pixel. To save you the long lecture, here I just referenced and modify whatever I can find online by typing three.js glow effect shader. What I essentially did here is just changing the brightness of each pixel by the angle between what it's facing and the vector pointing towards the origin, i.e. the viewpoint. So the center will be brighter and it goes dimmer towards the edge. Great, now it finally starts looking like an actual starry sky. But wait, there is still something missing. Ah yes, the Milky Way, our vast galaxy's billions of stars that are too far away to be distinguished, instead forming a gleaming ribbon in the background of the night sky. For that, we'll use a textured sky sphere. I'm able to find this source for texture for the sky sphere that is oriented to the equatorial sphere. You can think of the texture of a sky sphere like a Mercator projection of the sky, where you translate between the surface of a sphere and a rectangle. Now we finally have a beautiful night sky. However, as you can notice, our configuration has the celestial North Pole right above our head, meaning the simulation is always situated in the North Pole. To simulate the sky at other latitudes, we just rotate the whole sky dome by the east-west axis, shifting the north-south pole axis across the sky. And to simulate the rotation of the Earth, making us see the sky rise and set, we first keep track of how much the polar axis rotates with another vector variable, and just rotate the sky dome around that vector as the axis. I added a ground with grass textures and lines on the ground signifying the directions. And enough explaining. Pull up the B-roll. Just like my other projects, you can try it yourself with a link in the description. The code is also open source and downloadable on my GitHub. Feel free to play around with it. And that's it for today. If you liked the video, leave a like. If you don't, please leave a comment telling me how I can improve. And subscribe if you want to see more. See you, Nada!